I'm fitting a poor man's DRO to the Z-axis, Z-axis, depending on where you come from, on the Gingery Milling Machine. It's just a simple, cheap, digital vernier calipers. I'm mounting it to the spindle bearing cap. Now my spindle bearing cap, if you follow the series, you may remember that it's actually unusually thick because I wasn't confident that there was enough meat left after the, because Gingery must have used a 25mm or 25.4 1-inch shaft, but his outer diameter of the bronze bush must have been smaller than the diameter of the bronze bush that I used, and I would have only ended up with 3mm or 1/8 of cap around the bearing. So I built the cap up 12mm, half an inch, to give it more meat. So yeah, if you're using the standard made the standard cap that Gingery recommends for the spindle, this probably won't work. It's in this position because I can't go any further to the left because I need access to the spindle lock, the lock for the slide, Z-axis slide. That's why it's in this position. Then there's also the oil cap in the middle. So that's why it is where it is. Not important. So I've made up a stainless steel strap, and that's screwed to the jaw, one half jaw, and then I've made another strap that's screwed to the other jaw, and then bolts to the mounting bolt for the mill to the timber base. It feels like it's all the way home. When I drilled these two holes, I didn't strike the bronze bushing. Well, no goldy coloured bronze material came out of the hole, so I am presuming I haven't drilled into the bronze bushing, which would be good. I wouldn't like to do that. Okay, they're tight. Now for the other piece. Now I suggest not fitting something like this until well and truly after the mill has settled down. The spindle bearings have settled in. I'm a little bit out. That's better. So there we go, a cheap DRO for the Gingery Milling Machine. I need the position of this threaded hole in this bracket. So just could go a little bit lower maybe. Somewhere around there. It's alright, I can make the hole a little bit bigger. Let's see how that worked out. Well, I've created a cardboard cutout or a cardboard box for the X and the Z axis to bolt to, and you'll probably think, well, why do I have such a large area there? That's for the readout for the Y axis to sit on. That will go in. That will go in there. So all three, all three. The X and the Z axis will be attached to this, and the display for the Y axis will be mounted here. That'll give me a digital readout for all axes, which isn't too bad because that was a $20, $15 vernier. This was a $28 vernier, and so what have we got? We'll say $30. That's 45, and this was under 50. So for less than $100, I have all three axes. Okay, I'll remove this and start making something out of the box here is made. I didn't realise I wasn't filming any of this, so I think the last part you saw was me bending this back section here. Anyhow, I've made a box section. It now holds the anchor for the Z-axis. It also holds the anchor for the X-axis, and it will eventually, if I can find it, it will eventually hold the readout for the Y-axis. Hopefully. I've got tape on here. It's got two magnets in here, and I've got to pull it apart later and clean it out. Yeah, magnets and steel shavings. So it's full of rubbish. It's not the battery colour, so I don't have to worry about the battery. Anyhow, so that's the three. That's the three things that go onto that box. Now the X-axis bracket, I thought I was right, but I came across a problem. The problem was when I screwed the work table all the way in, the bottom of the screw support was up against the slide of the vernier caliper. So I've put an extension on here. Yes, it looks a bit ratty at the moment. I'll have to make up a new plate. But I thought, rather than commit myself to anything again, I shall confirm its position so that it is missed by the work table lead screw support bracket. So that's what I'm on at the present moment, and trying to work out where I'm going to put the DRO slide for the Y-axis, or the Y table. Yeah, I'll make that in another video, just discussing where and where it could go, but why it can't go. It's stressing me out. No, it's not. Well, it is. I'm annoyed with it. It's a difficult thing to sort out on such a small machine. Anyhow, leave that with me. I'll finish grinding these screws off, cleaning them up, so the head can fit on there. This is a cheapy vernier caliper, but man, this steel was so hard. I broke a tap off. Thank you very much. Birds. I broke a tap off. I had to drill these with tungsten drill bits that were about 20 odd years old. A normal high-speed drill just wouldn't look at it. Would not look at it. I tried to go hard and fast, so I didn't harden the stainless, but yeah, I don't know what grade it is, but it's very hard. And it's also magnetic. It does say stainless hardened, but this one here, nowhere near as hard. And does that say, yep, stainless hardened. It should say stainless not as hard as some. This one should be stainless very hardened. Don't try to drill. Stop your whinging. Catch you later. The problem I have here is this saddle is over to the left as far as it can go because it hits the motor housing. It hits the motor housing back here, so it can't go any further. So if I fit this on this side, that's the position. And the problem we have here, well, not so much of a problem